So for number 3, there's 4 types. It's either positive and a perfect square or positive and not a perfect square. Both of those produce 2 x-intercepts on your graph, and both of those produce 2 real solutions. The only difference is if it is a perfect square, that means when you take the square root, you get what kind of number? You get a whole number, so that's rational. Okay? Well, if it's not a perfect square, you always have something inside the square root. That's why it's irrational. Okay? So I want to kind of move away from some of just the memorization, and I want you to understand why they work that way. For example, when you have a 0, when you take the square root of 0, you're adding and subtracting 0. Why does that only produce 1 solution? Because if you add 0 or subtract it, you get the same answer, right? So it doesn't matter if you add or subtract. That's why there's only 1. Okay? If it's another number, you're going to produce 2 different solutions. So everything else has 2 solutions. Negative is the only one that's complex. Okay? Not a perfect square is the only one that's irrational. Okay? So when you're doing the discriminant, you are going to do b squared minus 4ac. So b squared minus 4ac, you're going to plug those into the formula. Whatever you get for your answer, that's your discriminant. So 0 is the discriminant. So whatever b squared minus 4ac equals, that's what you're going to write on the line. The number and type of zeros, the number is either going to be 1 or 2. Okay, that's what we just talked about on the bottom of this page, right? It's either 1 or 2 here. Okay, and then the type of zeros is either going to be real and rational, real and irrational, or they're going to be complex. Okay, so for this one it's 0, which means there's 1 real rational root. 100 is a perfect square, so for this there's 2 real rational zeros. I only gave you 2 to practice with. This might be a good thing where if you were having trouble with this last week, pick out some and see if you could label those. Okay, because you have to know all the types. That's why I had you do question 3, so you're ready for any of that. Alright, so for graphing the inequalities, you're going to start by finding the middle. What's that formula for finding the middle? Yep, opposite of b over 2a. Now, once you have that, 1, that goes in the middle, and then what did I tell you you could use to fill in your chart? Yep, you can use the table feature on your graphing calculator. Okay, do we need a review of that? How to plug that in and find that? Feeling good about that? Okay. Now, I do want you to make sure you span your graph. Like, this was a little graph, the 5 by 5. So when I say span your graph, look at the y values. If this was a 10 by 10, I wouldn't have stopped here. I would have kept going. And you're just using your table on your graphing calculator, so all you have to do is scroll. Okay, so you guys with me on the spanning the graph part? Okay, and then it's dashed. Don't forget that. How do you know if it's dashed or not? Good. Yep, inequality sign. Perfect. Okay, now your test point, you have to show me this part. So 0 is less than -1 is, and as long as you have that, I'm fine. Because if you're plugging in 0, like it's 0 here, -1 here, that's pretty simple. Now, if you were kind of nervous about using 0, 0 because it is in the border there, you can pick any point you want. Just tell me what the point is, show me the inequality, and then tell me if it's true or false. You don't have to write do not shade 0, 0. I'm just writing that for you. Okay? I got kind of sloppy with this. Really, I would want it like this. Okay? And then when you're shading outside, if you span the graph, then you're not going to have to worry about accidentally shading somewhere that you're not supposed to. So you don't shade 0, 0. If 0, 0 is inside, okay, you're going to shade outside. For B, when I say span the graph, this is a good example here. Because if you just found the center, the -3, 5, and then you stopped here, that wouldn't span your entire graph. That would only bring you to here. So again, you're just going to scroll on your table, okay? So down to -4, and then -11 was off the graph, but at least that gave me a point to go to, so I used that so that I could graph it.
Are you going to want us to, like if we span it, just to write down the -6, -4, mark the point?
Oh, no, you could just mark the point on there, that's fine. Yep. And then this one, 0, 0, was outside, so it was false, and I didn't shade 0, 0, which means I shaded inside. Okay, please double check that you have this equation, because I did notice like one or two people without it, so just make sure that's not you, okay, and that you have that on there. And then this one is solid. Are you guys feeling pretty good about the graphs? Yeah. Okay. Good. Good. All right. Now, the last page is about solving the inequalities, and then doing that using algebra. And you're going to have a table that's already set up just like this. So, the work that I need to see is your factoring. So, what multiplies to -48 adds to -2. One of them should have -8, one of them should have +6. Doesn't matter which one, but you do have to have the correct signs. If you don't have the correct signs, then your whole problem is going to be incorrect because your key values are going to be flip-flopped, right? You're going to have the wrong one that's positive and wrong one that's negative, or just the wrong signs. So to find the key values, you set these equal to 0 and you find your x value. So x equals 8. X equals -6, okay? Now, I know some of you are really good at just going from here to here. That is fine. You do not have to write this number line if you don't want to. This is for people that are more visual. I'm a more visual person. I like seeing each part of the inequality. So the first part of the inequality, the interval, is x is it less than or less than equal to? How do we know? Yep, the original. So whatever this is, if this has an equal to, these have an equal to. So you need the equal to here. Okay, the second one goes from -6 to 8. So x is in between -6, +8. And then this one here would be x is greater than or equal to 8. Your test point can be anywhere in this interval, it just can't be this number. So -6 wouldn't work, -7 would. Okay, 0 works here. Whenever you can use 0, highly recommend. And then you're going to plug it into the original inequality for this one. So -7 squared is 49, plus 14 minus 48 is greater than or equal to 0. 15 is greater than or equal to 0. Is that true or false? True. Okay, when you plug in 0, you'll get -48 is greater than or equal to 0. Be careful. Don't just say 0. It's not 0. You have 0 minus 48. Is -48 greater than or equal to 0? Nope. So it's false. And then for this one, when you plug in 9, 81 minus 18 minus 48, I believe you got 15 again, and that was true. What have we noticed about the way this table works? They always alternate, right? So if this one is true, this one is false. That's because these two border each other and they're saying opposite things. Could x be less than or equal to 6 and greater than or equal to -6? Could it be both less than and the greater than part? No. So only one of those can be true, right? Same thing here. X can't be less than or equal to 8 and greater than or equal to 8. That can't happen. So if you ever get 2 trues in a row or 2 falses in a row, something went wrong. You need to redo it. Okay? So if you have 2 true, you connect them with what? An or. Okay? So x is less than or equal to -6, or x is greater than or equal to 8. Okay? This is the and, those two are the ors. Alright, how'd that go? Good? Okay. Now, when you're doing B, what's the difference between A and B? For B, what do I have to do first? Yep. Because you need it to be less than or greater than 0. So 6x plus 5 greater than 0. Okay, so then when you factor this, you're looking for two values that multiply to 5. What are the only two values that multiply to 5? 1 and 5, right? Not 3 and 2. 3 and 2 multiply to what? Yeah. Okay, so it's plus 5 plus 1. So then your key values are x equals negative 5 and x equals negative 1. Okay, when you're doing the intervals, your intervals are going to be with an equal to or without? Without. And again, that's all based on this. Okay, so if there's no equal to, there's going to be no equal to in the table. Okay, so it's x is less than negative 5, negative 5 is less than x, which is less than negative 1, or x is greater than negative 1. And then again, you're just choosing chess points that are not critical values. So you can't choose negative 5. Negative 6 is great. Can you choose 0 here? No, 0's not in between those. So you have to choose negative 4, negative 3, or negative 2. Okay? Can I choose 0 here? Yeah. And then you have a choice for this one. You can use this equation or the original. Does not matter. Just write out which one you do. I like to compare it to 0, so I would choose this one. Okay, and then so negative 6 squared is 36. Minus 36 plus 5 is less than 0. 5 is less than 0. No, so false. Negative 2 squared is 4. Minus 12 plus 5 is less than 0. So I have negative 3 is less than 0. That is true. What do I know that one's going to be? Yep, but you got to show me your equation. Okay, so plug in the 0, false. Now your solution is always the which one? Whichever one is true. That's why I'm highlighting these, okay? So if this is true, then negative 5 is less than x, which is less than negative 1.